I'm going to have to post that last video, but I'm just watching this one out. And you got to watch out for some of these. These guys, I love the way he's a man killer, though, but it works perfect because I want to be in his Hamiltonian operator later on when we get lined up because of the readings, JSA pitch, of the show that the letters are going to be out. Somebody's going to give this safety meeting, not really read through it and understand what a very good Feynman catalyst would be in terms of an example inside of here. Let me actually get something I can move around. Why? Because you're copying. You are a kid copying a course because some business wanted me to do this while looking on here for white hat hacks companies. They're, what are they? Analysis or auditing companies. It depends on what name they have because of how subjective the name is, right? So inside of there, that's what you're looking at. You're looking at it here in a one-dimensional, it's ball form in all of its tiny subatomic particles. It's a baseball, and it's a baseball based in leather, string, and some cork, or whatever else makes this up. Leather is an item, it's cork. All that is the result, right? It's inside of there when I want to have a two-level system that serves an ability for me to click and copy before I get into a way of operating that. Instead of individually attacking each of these, I can build a dev system that later on produces the same Hamiltonian operator based on a time-dependent function. Where are we? Yeah, that's what we want. Based on a two-dependent system, because again, now it's in that form of a ball like this. 1, 2, 3 right here, but this might be that background one to what this is, right? But there she all is, all worked out. Or at least more worked out as far as this step in terms of its completeness, being able to handle all this. Realistically, I can still get in here and inspect and just copy some of this and throw in some of those notations, see how it works, debug it. Realistically, there's still problems with my padding or my margins that I had to integrate in here to get the same result of certain aspects of the situation. Here again, I'm using the main page, not the page that I need. Let's just use this. What would be the other one? Yeah, well, anyways, that's a version of it where it'll commonly work. We come in here and inspect and just say, I don't got the pictures in yet, or I've changed off this page so it doesn't work anymore. And that's one of the three things it could be, is a void state. From here, we could use that. It's just, pocket where there's nothing. The vacuums are important that way to not get things bumping around, your bubbles in your resin. Well, in the way, again, that's that Hamiltonian operator that we're looking for inside of here. Let's see if I can fix this up. That allows us to better program. For me, I've taken 2 or 3 days at this. I actually tried it a long, long time ago, and I got kicked off at probably the rounding of this because things are starting to switch around. You're deleting a lot of stuff. You're learning a lot of stuff about style points and then rendering them all together with certain link characteristics where then you delete them. And it makes the code nice and pretty, but you can also leave some stuff in there like a major point that later on, if that's going to be an important notation to one of these things, or how to integrate a checkbox. Checkbox is a checkbox, and it could be likes, could be ultra relative, truthy, falsy, check, look, don't look, because basically they're the same button in the same div. I mean, you got to know what you're counting because it's div day, and they're going to look different, but still the numbers work, so the code will still work. Where A and B, where A and we are A and B relative to each other. We're two time dependent systems. I know how to keep books, you know how to keep books. We'll make this a timed event. In itself, it's being timed. Is it worth the result that is I, the omega, to a 0, looks like a Ingling's value, it's t. As you're writing out these equations, it's not a natural letter. It's an irrational letter. It's a 1 and 0, on or off. Energy can't go through it or it will go through it, and it's kind of a mere chirality because it could be other way. But for the experiments on this test, t is the on statement for what it does. It's going to run for 0 and then it's going to turn on to t. So if we don't program that, there's you have to look at it like two types of MOS chips. They do the exact same thing, but one set to a high charge first, and that's how the information runs through because somewhere's in the circuitry. And the other one is our standard model. Well, our standard model and then the chiral variance on the charge. It wants to accept a high or a low. So there's my note for today.